Okay, train for a selected value of target out of 3 possible values. So suppose we want to train for a particular severity. Okay, so we have 3 possible values for maximum severity, right? So you want to train just for one of them. Okay, so we'll call this ACCNN1. Okay, accident neural network 1. Okay, now we say neural net. Okay, so we're going to use the neural net method, and max SEVIR. So that's the max SEVIR. That's the target. And then, so we want to train the model for predicting fatal accidents. Okay, so then we need to set this to 2. So 2 will be selected as the positive case. Okay. And okay, well, I have to specify the predictors. The predictors is going to be all of them, all the rest of the columns, and data equal to train.df. Okay, and let's say hidden equal to say 3. We want only one hidden layer with 3 neurons, right? So then linear output equal to false. And then we say plot ACCNN. I don't know why it's suddenly it forgot that it had the neural net. There you go. All right, so we have all the inputs, okay, 3 nodes in the hidden layer and just 1 output layer. Okay, so the blue lines are the biases, thetas. Okay, and then you have the weights here. We don't really care about weights as long as it converges. Now we want to predict. Okay, so we can use the predict ACCNN1 pred. Okay, well, let's say it out. It's not actually prediction. That's why I want to use the terminology out. So if you do predict ACCNN1 and then give it valid.df as the data, so that will give you, I misspelled here, so that will give you the predicted values. Okay, ACC, so that's the, so remember we had only one output node, so it gives you the predicted output function. Okay, they are not probabilities, as I said. Okay, so it only gives you the predicted value of the output function. So now we have to convert those values into actual predictions, whether fatal or not. So we can then do ACCNN1 pred and then use the if-else function. Okay. So here we need to convert this into a data frame. So is it a data frame? ACC N11 out. Okay, I guess if you want to see what kind of object it is, we can do this. So it's a matrix. So we really need it as a data frame. So for if-else to work properly, we need it as a data frame. We convert that into data frame, and then ACC dot NN1 dot out. Okay, and so if that is greater than some value, say 0.5, okay, we say it is fatal. Otherwise, it is not fatal. Okay. So now we have the predictions. So if you go to ACC N1 thread, so we have fatal and not fatal as the predicted values. Okay. All right. So to then develop a confusion matrix, we want the actuals also to be fatal or non-fatal. So right now, if you go to the valid data frame, the maximum severities are 0, 1, and 2. So if you try to run a confusion matrix between this as the actual and the prediction as fatal and non-fatal, there is not going to be a match. Okay, you will not have a confusion matrix. So the actual should also be either fatal or not fatal. So we have to create a new actual, then only we can run the confusion matrix. So again, we do an if-else. Okay, so if-else valid.df max severity, if it is equal to 2, then it is fatal, otherwise not fatal. Okay. So it should be the predicted and the actual must have the same exact levels. If they are different, then you are going to have an error. So now we are ready to do the confusion matrix. So we can do as factor the predicted values. So ACC dot NN1 predicted, and then as factor ACC actual. Okay. So now we have a confusion matrix between fatal and non-fatal. So with 0.5 as our cutoff point, quite a lot of non-fatal and quite a lot of fatal accidents are getting predicted as not fatal. You see, there are 50 of them. Okay. So sensitivity is very low, 0.15. Okay. So you may want to change this to a smaller value. Okay. Say convert that to 0.3, then sensitivity has now gone up to 0.37. Now you can run a ROC chart to see what is the best cutoff point would still be not very good. Okay, so if you do an ROC chart, you'll see you'll be able to check that.